Welcome to Garrett ComSci. This is CS Principles, Unit 2, Lesson 5, Packets. As a warm-up, consider that there's a roof leak in your school's library, and all the books need to be evacuated to the gym by the end of the day. What might the process look like? Well, speed is the most important thing here to avoid damage to the books, and so you'd probably grab a lot of people who would help take all the books off the shelves as fast as possible and maybe pile them in a box and take them down the hall and take them to the gym to be out of harm's way. You probably wouldn't be worried too much about what order they go in or having a big long list of all the books to check off one by one. You'd just be concerned with speed. Now imagine your school has just built a new library, and you have a month to move all the books into their new home. What might you do differently? Well, in this case, speed is not quite as urgent, and so we would be more concerned with having our library in a reasonable order and organization and make sure that all the books get there successfully. And so we'd probably have a system to make sure that each book is delivered and that it can be easily put back in order to make a well-organized library. So today we're going to be looking at two different protocols for sending messages across the internet. And one is for when speed is most important, and one is for when accuracy is most important. The activity today is again using an updated version of the Internet Simulator. So log on to code.org, Lesson 5, and open the Internet Simulator. And if you're in a classroom with a neighbor, join a different router than your neighbor. Ask your partner for their IP address that's assigned to them. And then on the simulator, have a back and forth conversation about one of these topics. And as you do that, try to notice every way the simulator is different than the last time you saw it. So let's take a look at the differences. Well, first, what's the same? Well, last time we already had this place where you type in the address of the device or person that you're trying to send a message to. And here's your from address that's already filled in for you. And then here's a place for the message that you want to type to them. But now you'll notice we have a limit for the number of bits that your packet, your message, can hold. And once you reach that limit of 80 bits, you can hit Add Packet to continue your message in another packet. That is, another chunk of the message. So packets have a limit of 80 bits long, and then you'll notice before you even start typing a message that 16 bits are already used for the to address and the from address. Notice they're 8 bits each, 16 bits together. So that only leaves us 64 bits for the message, and each character of ASCII takes 8 bits each, so that's 8 characters, up to 8 characters in each packet. And once you hit 8 characters, you got to add another packet to keep going. Let's quickly remember that metadata is data about the data, or about the main data. What's the main data on one of these packets? The main data is the message. So data about the main data, extra data about the main data, would be like the from and the to address. In this case, this metadata is used to route the messages from the sender to the receiver. You should have your activity guide open, whether your teacher requires you to fill it out totally or not. The activity guides on all levels are useful because they have thought-provoking questions, good hints, and more complete instructions than you see on the slides. Protocol 1 for sending our packets is like the first library situation where speed is most important. So to figure out what this looks like, go to the Internet Simulator and send a single message to your partner that has 5 to 10 packets. So see here, this is an ongoing message. This says, "This is a long message from me to you," for example. And so there's 5 packets. Make one ongoing message and send it to your partner. And after a moment, go then to the corner of your screen to the Router tab and click on this Log Browser button. Filter to your traffic on all routers, my traffic on all routers. Then read the traffic and answer the questions in your activity guide. Here's the things we want to notice. We want to notice whether each packet, each message, each piece of the message was successful in sending to the partner. We want to notice the route that it takes, so you want to see the order that it goes through the routers in the classroom. And you want to notice what order they actually arrive in to your partner. So do they all arrive at all? Do they arrive in the right order? Probably something fishy happened. So these are responses to the questions that you're asked on the activity guide. We'll notice that each packet in a message could take a different path to its intended recipient. Each packet is swimming through the internet on its own, trying to find the best route to make it to its intended destination. But sometimes things go wrong and a packet could be dropped. As a result of this, the fact that they can take different paths, messages might arrive out of order or incomplete. And while the recipient might be able to just look at it and kind of figure out what you intended to say, a computer could not just automatically put it back in order and fill in any blanks. So accuracy suffers a little here. So this protocol is simple and fast because we're not doing any extra work to check that it got there complete and in order, but it's not very accurate. The real-world protocol that's like this is called the User Datagram Protocol, UDP. That's the most important thing to remember, UDP. And this is similar to that first library situation where we were just trying to get the books down the hall as fast as possible to avoid damage. And so speed was more important than accuracy. We were not doing extra checking or record keeping to make sure that all the books arrived and could be put back in order. So the process here is to send all the packets, but don't do extra work to check. And we use this protocol when split seconds speed matters more than correcting errors. So imagine you're on Zoom or you're doing live streaming or online gaming. It's okay if there's a little glitch occasionally. It's not okay if it's buffering and lagging behind all the time. So speed is more important in some situations than accuracy. So what about Protocol 2? Of course, Protocol 2 is going to be where we do some extra work to make sure that everything arrives and can be put back in order. So if you're doing this activity in class, on the activity guide, it asks you to create your own protocol, your own set of steps and rules, and maybe message formats to make sure that these considerations are taken care of. Here are the things we want to consider. How will the receiver know the order of the packets when they arrive, or if any are missing? How will the receiver request missing packets, and what will the sender do in response? And how will both sender and receiver know the full message arrived successfully? So you can pause the video and come up with your own protocol that would solve these considerations. So the protocol that actually checks for these problems and allows us to confirm that our message is complete and in order when it arrives at the recipient is called the Transmission Control Protocol, TCP. So TCP does error checking. And this is like the second situation where we had plenty of time to deliver all the books to their new home. And we could do some extra checking, like we could have a long list of all the books and we could check them off one by one and make sure they arrived. And if anything wasn't checked off, we could go and look for it in the old library. And we could make sure that everything was being delivered in a reasonable order so that it could be put back in order and be a well-organized library at the other side. So how does this work? We number the packets. So we add something else to the packet metadata. That would be a packet number. And maybe even how many packets are in the total packets are in the message, so that they can be reordered and put back in order when they reach their destination. And so we know if we've received them all, because we know the total number that are supposed to be there. We know if any are missing. And so when a particular packet arrives at the destination, the recipient sends a little receipt back to the sender, saying, I received packet 2 out of 5, for example. And then maybe they receive packet 1 out of 5, so they send a receipt back that says, received packet 1 out of 5. And then they get 5 out of 5, and they send a receipt. And then they get 3 out of 5 and send a receipt. And then after a while, the original sender had not received a packet 4 out of 5. And so they just notice that and send it again. And hopefully that time they receive a receipt from the recipient. And so we just send these receipts back and forth called acknowledgments. And anytime a receipt is not received, it just gets sent again by the sender. And so this is any time that accuracy is important. So it's not okay if anything is missing or out of order. So when we do emails, send photos, or look at websites, we can wait a second, but we do not want anything to be missing or out of order. And here's our vocab for this lesson. And again, remember, there's a video that's available in your lesson resources that summarizes all of this very nicely. And then here is our vocab. A data stream is information passed through the internet in packets. There are two devices connected and they're passing data back and forth. A packet is one chunk of data sent over a network that comprises a larger message. And a packet makes its own path through the internet and therefore might arrive at a destination in order or out of order, or it might be dropped and not arrive at all. Packet metadata, data about the main data, is data added to the packets to help route them through the network and reassemble the original message. So this would be the packet number, and this would be the to and from IP address. That's all data about the main data, which is just the message. Then we have our two protocols. One is UDP. UDP is when speed is more important than accuracy, so we do not do much error checking. TCP is when accuracy is more important than speed, and so we send receipts back and forth and resend any missing packets to make sure, and we number the packets so that it can be put back in order and we make sure that it all arrives. And that's all for this lesson. I'll see you back here for the next lesson in this unit. Make sure you subscribe if you haven't already to see everything to come. Goodbye.